There are various ways to persist an RDD. You can persist it in memory or in the disk. Here, persisting in memory sounds very strange. It is essentially caching the RDD so that we do not have to recompute the entire RDD graph on every action. To make it very customizable, persist accepts an instance of StorageLevel class as argument. This StorageLevel class is a bunch of settings which we are going to talk about. You can create an instance of StorageLevel using the constructor as shown on the screen. The first argument is a boolean variable that specifies whether to use disk or not. Second argument represents if we want to use memory. In the example, we want to use both disk and memory. Therefore, both are true. The third argument is whether to use off the heap memory. The objects stored in heap are fast to retrieve, but are subject to garbage collection by Java garbage collector. The fourth argument represents whether to persist deserialized. By setting it false, it will store RDD as serialized Java objects, 1 byte array per partition. This is generally more space efficient than deserialized objects, especially when using a fast serializer but more CPU intensive to read. The last argument is for specifying how many copies do we want. For critical RDDs, we can have multiple replicas of RDD partitions in order to avoid recomputation on failure of machines. The default value of number of replicas is 1. It can go up to 40. Finally, while using persist, we can pass the StorageLevel object as argument. There are pre-crafted shortcuts for StorageLevels for various use cases, which you can use quickly as per your requirements without creating the StorageLevel objects. These shortcuts, such as the one shown in the slide, are nothing but a static object of StorageLevel class. Let us understand various pre-created StorageLevels and when to use each. It persists the RDD into the memory so that it does not get computed on every action in an application. It stores RDD as deserialized Java objects in JVM. If the RDD does not fit into the memory, some partitions will not be cached and will be recomputed on the fly each time they are needed. This is the default level. It stores RDD as deserialized Java objects in the JVM. If the RDD does not fit into the memory, it stores the partitions on the disk that don't fit into the memory and read them from the disk whenever they are needed. It stores RDD as serialized Java objects, 1 byte array per partition. This is generally more space efficient than deserialized objects, especially when using a fast serializer, but more CPU intensive to read. This is similar to memory-only serialization, but it spills partitions that don't fit into the memory to the disk, instead of recomputing them on the fly each time they are needed. It stores the RDD partitions only on the disk. It is same as the levels before, but it replicates each partition on 2 cluster nodes. It stores RDD partitions only on the disk. Spark's storage levels are meant for providing different trade-offs between memory usage and CPU efficiency. We recommend going through the following process to select one. If your RDDs fit comfortably with the default storage level, which is memory only, leave them that way. This is the most CPU efficient option, allowing operations on the RDD to run as fast as possible. If not, try using memory-only serialization and selecting the fast serialization library to make the objects much more space efficient, but still reasonably fast to access, Java or Scala. Do not spill to the disk unless the functions that computed your datasets are expensive, or they filter a large amount of data. Otherwise, recomputing a partition may be as fast as reading it from the disk. Use the replicated storage levels if you want fast fault recovery. For example, if you are using Spark to serve requests from a web application. All the storage levels provide full fault tolerance by recomputing lost data, but the replicated ones let you continue running tasks on RDD without waiting to recompute the lost partition.